And good morning, all my super friends. Thanks for coming along, and thank you to Sion for doing all the pimping on your stream earlier. That's probably why there are so many people here right at the start. It's just rolling straight on, watching Sion's Reflow Master. So here is where I do the reverse shout back, which is shout out, shout back. Which is where, if you don't know of Sion and his streams, you really should. And check out Unexpected Maker on YouTube. Good morning, everybody. Before I get into anything else, I acknowledge the traditional owners of this land. I pay my respects to their elders, past and present, and to Aboriginal elders and peoples from other communities who may be taking part in this live stream today. Now, unexpected here. So, I have a few different things to cover today, and I don't really have a sense of how long each of them is going to take, which usually means it will take about 10 times longer than I expect. So, this is interesting. I just got a warning off YouTube. So I am streaming off the ATEM right now. There is no OBS, it is just camera and microphone straight into the ATEM, which is streaming. And it just came up with a warning saying that my stream's current bitrate is lower than the recommended bitrate. That's not good. So there's something going on. Yes, Steve is back. Steve is back, looking over my shoulder. So, first off, I want to do a bit of assembly. I like doing practical things. Yes. My voice is your mic a bit weird? I don't know. Maybe. Is it clipping or doing anything bad? At the moment, I'm running the lapel microphone, which is going straight into the ATEM, and there's no... Oh, yep, audio and video certainly suboptimal. Okay, so that might be the buffering effect more than the equipment that I'm using. I wonder if that's because of my internet connection. It really shouldn't be. My internet connection is a 100/40. So... Well, this sucks. I've done everything I can at my end to be running this without any bottlenecks or anything bad happening at my end, and still the internet connection is being a problem. Dalek-like, yeah. My guess is that there is some extreme compression going on with the bit rate being low. I wonder if that is a setting. Okay, I am going to look at ATEM settings. Yeah, OBS for the win. Yeah, I just need a computer that will do it. So what I'm wondering is whether the settings on the ATEM are turned way, way down. It's possible that it is streaming at, it might be set at a very low bit rate. Right. Output. What have I got? The platform YouTube quality is because I'm on the air, I can't actually change anything. It says that it's running at 400 kilobits per second. That is my current upload rate. 474 kilobits per second. Yeah. Alright. The problem is that if I try to stop this is unlike with OBS. I can't just restart OBS and have the stream maintained. I'm going to lose the stream. So the big question is, do I ditch it and mess around with ATEM settings, which may not even be the issue, or do I just keep going and hope for the bandwidth to improve? Okay, I think I'm just going to keep going. Yeah, alright. I'm undecided. Lose it and get it better? Yeah, I think it's worth it. It may actually continue on this same stream. I don't know what's going to happen. So if I click off air is it going to just drop the stream and start a new stream? I don't know. Alright, ditch it. Alright, it's bad. I'm going to ditch it. So, what's going to happen is, I am going to take the ATM offline and then bring it back online. That may start a whole new stream on my channel. I don't know. So let's find out. Here we go. I'm going to turn it off now. Okay. Has it come back on the same stream? Yeah, the audio... Oh, it kept the ID. Very good. Blurriness I can deal with, but the audio is very garbled. Yeah, it's hard when you're watching a stream and the quality is bad. Yeah, suddenly better. Fantastic. I'm glad that it kept the ID. That's really good. So I changed the stream quality. It had no stream quality selected at all. The entry in that config option was just blank. So I just selected streaming high. Hooray! Hooray! Okay. I really hate the fact that so many of my streams are talking about the problems of trying to get my streams working. It's just annoying. I don't like that. So let's get on to actual interesting stuff. Now, okay. So for the Open Hardware MiniConf that took place as part of LCA, when was it? 3 weeks ago, something like that, a bit longer. 6th of February now. No, yeah, about 3 weeks ago. One of the soldering kits, which we haven't actually shipped out yet, was the party button designed by Steph Piper. She does a whole lot of artistic, creative work, including with art PCBs. And she sent me a package with some of her soldering kits in them. So just in case you haven't seen these, this is her Etsy store, and that's Steph right there. And so she makes all sorts of creative things like stickers and what is this? Sparkle stickers holographic. Okay. The electronics poster A2 digital download. Things like bags with LEDs around them and copper tape for making wearable art projects and all sorts of stuff. But what she sent me were a couple of these little soldering kits and a couple of these. So this thing looks really, really cool. I've never actually seen one in real life. I've only seen pictures of them, and it looks neat. So this structure that you can see here is actually all made out of PCB. And I've got one of those kits right here on my bench, and I'm going to assemble it because I like soldering. I know it's weird, but I have that sort of feeling. Sometimes if I'm trying to do, there's a very noisy bird out there. If I'm doing manufacturing and I need to assemble a heap of things, it's just a chore. Like sitting there and putting connectors on boards, spending hours and hours just doing hand assembly, that can be a real chore. I don't find it too bad though, because usually what I do is just put on something like a podcast and listen to it while I'm working, and I can sit there for hours and listen to something interesting while not really thinking about what I'm doing and just doing assembly. But this sort of thing, this is fun. I like doing this sort of soldering assembly. It looks really really creative. So yeah, the effort and the creativity and skill that's gone into this design is amazing. Anyway, we will see more once I get the box open, because I haven't even opened the box yet. This is going to be like a live on camera thing. How can I get to this? There, overhead, yes. All right, so what we have is a couple of these soldering kits. So these are the little badges or pins, and this is made out of PCB material, it looks like. I haven't opened either of these, and I don't think I will, because maybe these need to go to someone else. I don't know who yet, but someone. So it comes with a battery and battery holder and an LED and a couple of LEDs and a switch. So you put all the parts on, solder onto the PCB, and it's got a thing through here which is the like a little pin with a clip on the back, so you can wear it like a badge. They're really cool looking PCBs. And look at all the colors on it as well. It's interesting the way she's got all this effect. So this is obviously Enig because we've got the gold finish on these lines. But there's blue here, there's purple here, there's a deeper bluish purple here. And on this one there are several shades of green and there's blue. And I'm actually curious to know how she did that. I think the difference is that it is a combination of the gold is the bare. Actually, let's get into the other kit. All right, I'll put these two aside. Those are cool, but this is the one that I really want to look at. Lamp Soldering Kit. Ages 8+ with adult supervision. So I'm going to need a soldering iron, solder, pliers, and cutters. I think I can manage all of those things. I wonder if the instructions are inside. Snap out the pieces to make a 3D lamp. So, also you'll see in here alki.com.au. That website is actually defunct now. So if you are interested in this, and this all sounds like a big infomercial, doesn't it? But it's not. This is just because Steph has done some really cool stuff. In fact, I'm going to drop the... is there focus on that camera? It looks okay, I think. So I'm going to drop the URL for this soldering kit into the chat, just in case anyone is interested. And yeah, I think I can probably improve that focus just a little bit. It's on the overhead camera, and if it's on manual focus, because I find that if it's not on manual focus, it focus hunts. Those Panasonic cameras have really, it'll jump out of its focus assist mode in a second. There we go. Yeah, they have really annoying autofocus. So we've got a little bag of parts. We've got there's an LDR, light dependent resistor. So that's how it detects when it's dark. Battery holder, there's a transistor, and what else? A switch, LED. Can't really quite see what's in there. We'll get to that. So this is the PCB, and it's all done. So it's been panelized. You can see it's got the little breakaway tabs with the mouse bites. It's got holes drilled through here. Tiny glow lamp, cat soldering kit. This looks so cool. So we've got like a matte black finish, there's a gold finish, and a gloss white. And the way these colors are achieved is pretty obvious. It's just a matte black Enig PCB with white silkscreen. And so getting those colors, yeah, that's pretty straightforward. But these ones, I'm pretty sure the way this is done, it might be hard to see on camera there, but there is a deep green, a pale green, and blue. So this is done by using a green PCB material, so the fiberglass is green, and then where I'm just thinking about this. So we've got blue, the blue would be the silk screen, but we've also got white. Yeah, I was trying to figure out, okay, so there's a combination. You can do bare fiberglass, bare copper, or in this case gold. You can do the gold with silkscreen over the top, gold with solder mask over the top. You can do the silkscreen, which is usually thick enough that it covers everything else. You can do the solder mask. So the question is, how did she achieve the two different colors of green and the blue and the white? Because what I thought was that the lighter color of the green would have been done by putting the solder mask over the copper. But anyway, very clever. So what else have we got here? Okay. Instructions. Good. Very nicely made. Oh, it's the instruction sheet is so big. I'll hold it up to the camera there. The instruction sheet is so big that it's not even all visible on the overhead camera. So it's got explanations of parts and watch assembly video. Oh, handy. Okay. Hopefully I will be able to manage it without doing that. Names for all the different bits, photo resistor, resistor, and parts we'll need. Okay. Snap or twist out all the pieces using pliers where needed. Yeah, I'm going to do this carefully because I really don't want to mess this up. I don't want to bust it. This is the sort of thing that looks really, really cool when it's done. Now, right, so Sion says, think they're using dual solder mask colors from PCBWay. Yeah, okay, so with PCBWay you can get multiple solder mask colors. Now I'm going to snap this one off. I might actually get a file once I've snapped it, because when you cut these off, let's chuck that under the microscope, and where are we? Here. Is this going to work? I don't have enough inputs on the ATEM, so I'm using an external HDMI switch that then feeds into the ATEM. So what you can see here is the residue left over from snapping it off. Because if we look at this bit under the microscope, you can see just here, that's the little snap off tab, and there are holes drilled across it, so that when this is broken out, so this can be snapped out of the carrier, but it leaves these little rough edge bits. So I think I'm going to snap them out, grab a file, and just clean that up to make it all really, really nice. Now back to overhead camera, which goes black for a moment because the HDMI switch takes a moment to change. And this is I'm being really cautious with this because I don't want to damage anything. It feels like I might break something when I'm getting it out, but hopefully I won't. I don't just want to apply lots of force. I'll try twisting this one a bit. Yep. Now this one in particular is going to be hard because it's supported from both sides. Now I think what I'll do is I'll get this one out of the way first. And that way I can possibly even just cut this carrier and that'll free it up. How about the cat arms or paws? Those out. And this one. Yeah, I'm sure it's fine. PCB is really, really strong. It's actually surprisingly strong. I don't want to snap it out of there and then have it bend the PCB here. I want to keep it all straight. All right, I'm going to go for pliers because that's going to allow me to apply a bit more localized force. So what I can do is, yeah, that's it. I can twist that out and break it without stressing the rest of the PCB. So now I should be able to work that backwards and forwards and get that off. So this is the little one that worries me. Well, maybe it won't be as bad as I think. Oh, that's all right. If you just twist it backwards and forwards, that ends up coming free. Okay. So that's just the carrier, which can go in the bin. What have we got here? Base. All right. Oh, you can see. Oh, you probably can't see. Oh yeah, these ones, I don't know if this matters. When this is put together, what do we see of this? Goes that way. I think we do need to get these off. That is... Yeah, well you can see in the photo here, if I switch back to the microscope, I'm going to put the instructions under the microscope. Oh, it's having trouble there. Turn the brightness way down so that you can see it. Yeah, look, in the photo, you can see that the little break-off tabs are holding it up off the bench where it's being photographed. these little whiskers. So I'm going to, I don't think I have one here. I'm going to grab a file. I've got a set of files here somewhere. Actually, I've got a large one out here. I'm all the way out in the garage now. Oh, I have several options. I think I'm going to try using the large file. So I've got, come on, change views. That's it. So I've got a large file. I've also got a set of lots of little files. But these need quite a bit taken off. So this is going to be generating fiberglass dust, which is nasty. So I'm going to have to vacuum after this. And definitely don't breathe this stuff in, because it's rubbish for your lungs. Now, I need a better way to be able to see the chat when I'm over here at the bench. So I'm kind of a bit of a distance away from my computer right now. I can see the chat off in the distance, but certainly not enough to be able to read it. That one? Oh, yeah, that one looks okay. Yes, I'm going to try to assemble this carefully, like in a really neat way, so that it is as presentable as it deserves to be. Yeah. Get rid of all the edges. Well, while I'm doing this, I could be asking you what you've been doing on the weekend, but I can't read it. So, what will I talk about? I need something to talk about while I'm doing this. Or I could just sit in silence. Yeah, let's not do the sit in silence thing. Okay. Quick time to jump back to the chat and see what you're all up to. Should display the chat by a laser on the wall. Yes, I don't have a laser projector like you do. Oh, Andy says, I'm waiting for the Superhouse to be Evil Steve squirrel shaped PCB. Yes, that really should be done. Mako says, John, please don a mask. Yes. I normally have a mask hanging right here. Where is it? Where is it? Maybe I've got one out here. You know, in this day and age, we normally have masks everywhere we go. You can't not have a mask. All right, seems I don't have a mask handy, but what I'm going to do is just finish this off, and then I'm going to vacuum it. So, put that out of the way, and subject you all to the horrible noise. Hang on, I am actually going to hit mute on this just for a second. Okay, and I just vacuumed up one of the PCBs. So, all right, so now I'm going to defeat all of my good work by having to open the vacuum cleaner to get it out. Here we go. But at least I won't be... There it is. It was one of those. But at least the dust won't be floating all around the place now. Oh, come on, why won't that click in? That's better. Right. So, where do the instructions tell us to start? I think with putting the parts on the base PCB. So, snap everything out. Insert the LED, transistor, resistor, and photoresistor into the cat body board. Okay, that's this one. And which side do we... Oh, cat body. No, this is the cat body. and we'll get ourselves some parts. Cat body board. So we need the LDR, the resistor. All right, photoresistor. Is this the right side? I assume that they go on this side. Yes, they do. So what we've got is the presentable side towards the front, which is that side, and then the parts on the back. It'd be nice to use surface mount parts on this so that there's nothing visible through here, because that way you wouldn't have the leads coming through. It may not be as useful as a soldering kit though. Alrighty. Where's my little handy dandy through-hole lead bender? It's a little 3D printed thing. What size do I need? Is that one? Yeah, I think it's that one. It comes with these tiny little, what are they, 1/8 watt through-hole resistors, which are cool. I like these tiny little through-hole resistors. So 100K, okay. Put that through there. I've got a few 3D printed things that I use. I don't use this very often because I almost never use through-hole parts. But this is a lead bender. So as you just saw, I could put the resistor across that, fold the end of the leads down, then you get nice 90-degree bends, and you can do it at different lengths. I think these are 0.05 inch increments, because those are the common spacings that you see on boards. What else have I got? Oh, this is a wire holder. So if you've got 2 bits of wire and you want to solder them together, you chuck that down and then you get 1 piece of wire and sit it in that one piece in that one, and it just, they jam into these little triangles, little grooves, and it holds the 2 bits of wire in place, and then you can use a soldering iron and solder, and nothing moves while it's all hot and you're not burning your fingers. So this is actually quite handy. I use this a fair bit. Oh, there's a radius gauge. This is really cool when you're trying to make enclosures for things. So say I wanted an enclosure, and this is not a great example because it's a circle. I could just, if I wanted to figure this out, I just grab the calipers, chuck it on there and go, oh, it's 22.5 millimeters. But what this lets you do is figure out the curve of things. Trying to find an example. Okay, here's a good example. Say this enclosure, this little container, and I wanted to do some 3D design and match that curve. Now the thing is, how do you find the radius of that curve? Because you can't, well, what you can do is kind of eyeball where the center point is and then measure to the center point, and that's the radius, or double it out and that's the diameter. But what this lets you do is basically just go, is it that size? Oh, look, it's 10 millimeters. There's a little bit of a gap in the middle there, which means that it is, it's bigger than 9 on that side. It's butted up against the middle, but it's a little bit loose on the edges, so it's smaller than 10. I mean, smaller than 11. So that is a 10 millimeter radius. So yeah, then in your modeling software you can model it to suit. So a little, it looks like a bat boomerang. Yeah, a little edge radius measuring tool is handy as well. What was I doing? That's right, I was making a cat. Making a cat. So let's solder on the first couple of bits. I am going to use my voice assistant now, so okay, if you need to hit that mute button on She Who Shall Not Be Named, I will say, Alexa, please turn on the soldering iron.
Okay.
All right, solder. What else do we need?
O-L.
No, Alexa, stop. It was spelling solder. Now, yes, I know this is a strange thing to do, but I tend to, come on, change. I tend to solder under a microscope all the time, even if I don't need to. Like for large stuff, I'm just so in the habit of it that I do it automatically. And I really like doing it. So it helps with watching the flow of the solder. You can really tell what's going on. So once this is done, like not on the stream but after the stream, I think what I might do is chuck this in the ultrasonic bath as well, because that'll get rid of all of this flux residue from around here. So and make it look really, really nice, because I want this to be super presentable. All right, transistor in place, LED in place. Make sure the anode goes to the plus sign. And it's not really sitting down properly, so I'm going to have to tack a pin and then reflow it as I smush it into position. And do some smushing and some smushing. Get that solder smoke heading into the air filter. I think I've checked this in the past. I don't think you can hear that air filter. It looked like the solder wasn't really taking very well to the lead that time, which is why I kind of reflowed it with a second round. Trying to get some more flux activation happening there. All right, where are we at with this? Got parts in. Let's do some lead cutting. Hold the leads so they don't zip up and, well, worst thing of all, go on the floor, because then they get stuck in the wheels of the chair and grind into things. I hate cutting leads and having them flip around the place. If any flick off, I obsessively go hunting for them, because it's really bad to have off-cut leads just lying around. Okay. All right, handy dandy instructions. What have we got next? Oh, look, I didn't notice this. Steph's put a little how to solder thing in here. It's soldering iron solder, gets very hot, etc., etc. Little cone shape of solder, snip off the ends close to the part. Cool. Oh, explanation of the orientation of the LED. Ooh, that diagram is actually not, well, if you ignore what's in the body of the LED, that's good. It's just that what's inside the body of the LED, that structure, that's backwards. If you've got an LED that has had its leads cut off, and yes, I know there is usually a flat on the body. Let's have a look. Let's find an LED and I will show you what I mean. LEDs, grab a blue LED, because blue LEDs have clear bodies. So this is a random little bit of information that is a bit of a, it's a squirrel to chase. But let's check this out. Back to the microscope. Where am I? There, about there. Okay, so the way I remember this is, now if you look at the, let's get it oriented which way around. It really doesn't matter, but I'm going to say positive on the left, or anode on the left, and cathode or negative on the right. So what you can see here is the two leads of the LED. The longer one is the anode, or the positive lead. Now, I'm just going to slide this LED down so you can see the body of the LED. And in the body of the LED, you can see that it's actually a bit hard to see through this. Let's adjust that lighting. Yeah, there, you can see it. Now, in the body of the LED, you can see that the cathode side, or the negative side, has a large body, and the anode, or the positive side, has a very small body. The lead comes into the case, and then it just protrudes inside the encapsulation. Whereas on the other side, the metal structure is very big. So if you have an LED which has been cut off, say it's been soldered into a PCB and removed, and the leads have been cut to the same length, how do you tell which way around it is? One way is that there is a flat on the body, but ignoring that, the way I remember it is that, I'll see if I can get it all in view at the same time. Yeah, the way I remember it is that the, right there, I think you can see it. It's like it's offset. Imagine that there is the same amount of metal used on the two legs. It's just that the positive one comes out further to here, and there is less of it inside the encapsulation. And the negative one doesn't come out as far, but there is more inside the encapsulation. So if you're just looking at the body of the LED, the one with less metal inside it is the positive, and the one with more metal inside it is the negative. Okay, that was a weird little tangent to go on. But, and of course you can just use an LED tester or something. Much, much easier than what I'm describing of that. Oh, I don't know. If you can just look at it and know, that is kind of handy. Okay, so next step is we need to solder the battery battery holder and switch onto the base below the artwork. So we've got the battery holder and the switch. So which one is lower? The switch is lower. I'm going to put that on first. And the reason for that is so that when I put it down on the bench and put weight on it, it's going to, I'm not going to bother switching views now, I'm just going to solder this. It means that it's going to be pushed flush against the PCB on the other side. This is it's not a bad little switch. It's got a fairly long stem on it. But I'm having trouble getting the solder to flow onto the pins. Have a look at this. This is a little unfortunate. Come on. Switch inputs. So I'm going to turn this off because I think the light coming from the side is going to make it harder to see and bring this brightness up. I'm getting kind of dry joints here. The solder is, you can see that it is holding back a little bit from the pins. It's not really fully bonding to the pin. I think there's a little bit of tarnishing or something on the pins of the switch. So, in flux we trust. Flux to the rescue. And I'm just going to introduce a touch more solder as well. And a little bit of that flux should help it bond to the pins. Although this middle one still doesn't look like it's bonding properly. Yeah, well, it'll probably still work. Ah! I'm trying to give myself another soldering iron burn. Okay. Now, the battery holder. This battery holder has mounting stakes. That's interesting. That's a kind of weird design. It's got mounting stakes sticking down underneath it, which would normally go into holes or something, and then it's got these structures on the bottom that are spacers. Doesn't matter. It's just, once it's actually on, if you can look down there, there is a gap, like quite a big gap. It's like 4 millimeters or so. The holder is supported sitting up above the PCB. So, soldering time. And now of course I've got flux on my hands because I just grabbed the end of this PCB without paying attention, and there is flux all over this. I should probably go and wash my hands before I do much more, or I'm going to get sticky stuff all over this kit. Yeah, that looks alright. Will I? Yes, I will. So continue doing what you have been doing, which is talking among yourselves, because I've been totally ignoring you. And I'm going to see if I can get this flux off my fingers. It's, what is that flux? It's a tack flux. And tack fluxes are really sticky and horrible. What is it? Chip Quick. Yeah, it's the Chip Quick no clean tack flux. It's what I've been using for a few years now, and I quite like it. All right, what have we got? We have that in place. Now where are we up to? Insert the cat body into the base, matching the positive and negative symbols. Solder the tabs to the gold pads in the base. Solder the remainder of the tabs together. Okay, so cat into base. And here we go. So we've got positive and negative, and here we've got positive and negative that you can see. It's got to go the other way around, so it goes like that into the base. And then, so we've got positive that side, positive there, which looks good. And I'm not sure that I've got this the right way around. Oh, hang on. Have I got it in the right location? Is it meant to go there? Because it looks to me like there is meant to be... Where does this go? It looks like this is meant to go in front of the cat. Or is that the front? Okay, I think that's the way it goes. Positive, positive. Yeah, judging by that photo. So the LED goes there. Yeah, I think that's the right way around. Okay, so it says to solder the cat into the base, positive to positive, and I have positive to positive, so let's do it. And for this soldering job, what you can see is there are tabs on the bottom of the PCB, and there are these tabs on the vertical PCB, so it slots through to get its physical structure. And then by soldering into those voids there between the pads, it'll lock those two PCBs together. So what I'm going to do is just tack one of them in place, because I want to be able to adjust its location. Come on, get some solder in there. So I'm not keeping them really well aligned right now, I'm just getting it soldered. So it's probably all skew with. Yeah, you can see it's a bit wonky. And then what I can do is, doing some creative holding, I can reflow this and adjust the position and let it cool and solidify. And hopefully now it is all sitting down flat. It's not quite straight though, so I'm going to reflow it again, change the angle. And I think I just, I removed the fillet between the two pieces. Ah. I am totally failing at this. It's I didn't get enough solder in there, so the fillet is not staying bridged between the two pieces of PCB. So I'll feed some more solder in and let it cool and solidify. It's very tempting to move it too soon. Alright, I need to fix the alignment. There we go. Now I'll just let it sit here for a moment. Whenever I'm doing these sorts of structural joints, I tend to move them while they're still just a little bit cool. It's leaning very slightly. I really want to get this right. I want it to be the sort of thing that can sit on the mantelpiece and look cool. I don't want it all wonky. Yeah, that looks straight. Okay, so now I can solder the other one. And hopefully it'll be mechanically locked in place. Come on. I should have used the bigger chisel tip for this. Okay, is that done? Yes. Ooh. I'm not going to stress it too much, I'm just testing. Yeah. I think it would be stronger if it also had pads on the other sides of both of these, so it was soldered on both sides, not just one side, which allows it to move just a little and stress those joints a bit. Okay, so now what's next? All right, instructions say solder the remainder of the tabs together, connecting the torso and arms and standoffs to the base to make sure it stays together. Okay, assemble the rest of the parts. So that's basically do the rest of it. All right, let's do the rest of it. I'm going to, what do we start with? Let's get these little base pieces into position, because that way it'll sit nicely on the bench. I should probably just be putting one of these in and soldering it at a time, but hey, let's live dangerously. There we go. I could probably put a rubber band or something around it to hold them all in place. I wonder if I've got a rubber band here on the bench. There are usually a few around somewhere. Oh, here's one. I don't know if this is going to make it better or worse. All right, this rubber band is too long, so I'm having to double it around. Okay, so that will hold all those in position. Now I've just got to be careful not to melt that rubber band. Oh, also this one needs a little bit more filing. So, oh, hang on, I just got a message. What was that? Something about my picture-in-picture is hiding your soldering efforts. Oh, okay. So I need to hold it over here a bit more. Okay. Yeah, okay. Let's stick some solder in here. Because of the odd shape of it, it's actually, look at this, it just rolls around on the bench. It doesn't have any stable angle that you can put it at in order to do soldering. So let's start with, and yeah, the angle is quite awkward. If I hit that rubber band with the soldering iron, it is just going to go sproing. I kind of laid a fair bit of solder into there. Looks all right. Let's go to the other side. Yeah, I think what I'll do is just solder them like that with the rubber band in place. Yeah, I've got to remember to keep right over to this side of the bench. And because I'm not using OBS, it's not trivial to just drag around the picture-in-picture thing. I've got to go into the 8M config software and use, numerical values to change the position. It's not as simple as going to OBS and grab a corner of it and just drag it to change its size. It's all number input box driven in the user interface. No drag and drop at all. Now, I have a sneaking feeling that I am not going to get to that Rack 32 firmware. All right. How is this looking? Oh, it's nice and stable. That seems good. Now, I need something to simulate a vertical surface. Okay, imagine that this is the bench and that we're sitting on it like that. Or like that. So it's got a nice solid base now. Alright, now how do I do these arms slash paws? So we've got, I don't know which one goes in which, in where. Oh, hang on, I see. So this goes through that way. What I don't know is whether the solder pads go on the top or the bottom. My guess is the bottom, because I think Steph probably designed it so that they are concealed. Ah, does that just sit in there? Interesting. Now, I'm going to have to look at this picture. Where is the picture of the thing? Alright, so when it's that way, we want the straight paw in there. And we want this paw in there. So I think what I do is just solder this together and then slide it over the body. That's what it looks like to me. But that doesn't work here because that... Oh, do I turn... I think I've got it turned backwards. I do. Or do I? No, it is backwards. So that paw goes that way. Just trying to compare it to the picture here. That paw goes that way. And the back paw goes that way, which means this has to go up that way to make those align. There. That now looks like the photo. Alright, so I'll have a go at soldering these on. This is a really interesting soldering kit. I really like the way Steph has set up the structure of this, using PCBs as structural material. Kind of like the way the RGB LED cube works, like the Freetronics cube. So, that one in there. Oh, and this is similar to the... Oh, I didn't get that very straight. The little control panel buttons that I showed on the stream a couple of weeks ago. Is it straight now? Yes. And that's straight? Yes. Okay. So the arms, or front legs, cats don't have arms, just slide on like that. Alright, so now it's starting to look like a cat. What else do we have? One other piece. Just this one. And that goes on like that, I believe. Yep, we'll let those arms fall out. Legs! Let those legs fall out. And I will solder this in place. Once again, I'm just going to tack it initially so that I can fix its position as I reflow the solder. Alright, now pick it up. As you can see that it's at a bit of a skewed angle there. So I'm just going to hold it, let the solder reflow, straighten it up, let it cool. No, still not enough. In fact, I'm going to hold it like this, do it vertically so that I can see the angle better. And then hold it. It's a little bit too far the other way now. Alright, reflow, angle, and that should be about right. Yeah, that looks good. Now I'll do the other one to give it more strength. really get some solder in there. And that's it. On, off. Okay. Now we have our funky little kitty cat. Oh, minus arms. So arms go, legs. Legs go in there. Now it's a funky little kitty cat. And we got a CR 2032 coin cell. Let's chuck that in, because I think we're done with the assembly. There are no other parts left on the bench, so that seems to be it. Oh, that slides under. That's kind of annoying. There we go. Did I get that? Yeah, positive. Up. And turn that on. Ooh, look at that. It works. It does the light detection thing. Let's get this back in place. So you can see there that the LED is off. In fact, you might have a bit of trouble telling that. So, Alexa, turn off the office lights. It didn't hear me. Alexa, turn off the office lights.
Okay.
All right, so it's a little bit darker now. And if I put my finger over that LDR, see the LED comes on.
Here's
Take it away.
I found on the
No,
web.
Alexa, stop.
Okay.
Oh, look at that. The LED responds to the light level. It's not dark enough in here for it to... Oh, it just glows a little. If I put my hand over it to shade the LDR, you can see the LED start to come on. I'll just turn it off and make sure that the off switch works. Yep. Alrighty. So, we have a little decorative kitty cat night light. So at night, the LED will glow blue. Just enough to be able to... oh, what's going on there? I think it was... Oh, I was putting it partly into shadow. Hooray! Nice work, Steph. That is really, really cool. I like this kit. It's more challenging to build than your average kit. Just, it's very simple in terms of the parts. As long as you get the transistor and the LED oriented the right way around, then you wouldn't have any trouble assembling this. Like even a real beginner could assemble that. But the challenge is in the mechanical side. All of the little tabs and things and the way these PCBs fit together. That is clever. Very cool. Okay, now, I reckon, how long have I been? I've been streaming for an hour, and I reckon for the last 45 minutes, I have not even looked at the chat. So, what are you all talking about? What is going on over this side of the world? Now I'm sitting in the dark. Hey, Johnny, you're proud of my soldering. Thank you. Kit E-Cat, or the kitty cat. So, does the shoulder knot? Oh, Steph is here. Piper 3DP in the chat is Steph. So this is, hang on. This is Steph's kit. I've got to make that LED glow again. There we go. Yeah, this looks amazing. It is such a cool looking project. It's and from the back, the interesting thing is that the parts on the cat, like if I had this sitting in a room, yeah, Steph, I'm not sure which way around you intended for this to be, but to me it looks like this is the natural orientation. So all the parts are on the back of the PCB, and they're hidden. So what you would see is maybe the glow of the LED from behind, but you wouldn't see it directly. So you would really only see it in quite a dark room. But the artwork on this side of the cat looks really cool. This side of the cat is more plain in terms of the artwork, and it's got the parts on it. and that side shows all of the really, really cool artwork on the body of the cat. Now, that's right, what was I saying? Back to the chat. E-Stig V2.0, I want a cookie. What? What is E-Stig up to? Who is E-Stig? Designed to the fronts of the LED backlights. Yes. Cool. Thanks, Steph. Now, at the risk of breaking everything, this lighting actually looks cool. Like with the lights off in the office, I'm just looking at the preview monitor. It actually looks really funky. I'm kind of a floating head because of the black t-shirt. Johnny said, how long does the battery last? I don't know. Should last quite a while if there's no leak, or minimal leakage through that transistor. A wagon load says, I like to pre-tin my parts before soldering them. Makes it easier. Yes. For those of you who don't know, pre-tinning means, yes, I'm Holly. Pre-tinning means putting solder onto the leads of parts before you actually fit them into the PCB, just to make the solder adhere to the surface, and then you put them in and solder them. You have to be careful though not to put on too much, because it can make the leads thicker and then you can have trouble getting them through the holes. So if you pre-tin the parts, you need to do a clean job of it and like wipe the soldering iron down the lead so that it doesn't leave too much residual solder on it, just a skin on the surface. Needs a pink LED. Yeah, I don't know if if I have a pink LED in, no, I don't in through hole. I'm pretty sure I've got pink LEDs in surface mount because I've got that funky surface mount LED kit. I don't remember seeing pink LEDs in through hole, only in surface mount. Right. Ooh, Piper says, I have a stash of those, fear not. Excellent. Now, what I was going to talk about next, and this is, yeah, let's go back to, where are we? I'm just figuring out all the ATEM stuff. So if I can go back to there and there, then we should have the desktop again. So for those who are interested, perhaps you know someone that could use a soldering kit, something like this, as a gift. These would make great gifts. It's the sort of thing that keeps someone occupied for a while as they're assembling it, and then they have a really nice end result. Not only do they have a nice end result, but they can feel pride about the fact they assembled it themselves. So, yes, they are a really cool thing. If you do want to grab one of these, hang on, I know I dropped this URL earlier, but for those who might have come along in the meantime and wondered what the hell I'm assembling one of these. It's one of Steph Piper's cat soldering kits. So check them out. They're awesome. Looks so good. Yeah, so that's the natural orientation with the parts on the back of the PCB. Now, another thing I was going to talk about is, this is a subject that I mentioned in the chat on Sion's stream like an hour and a half ago, and he said, no, don't talk about that, is credit in open source projects. And one of the reasons that I've brought this up, this is not a subject that I thought of bringing up, and I know that people have feelings about this. And also a related subject, I can't remember who, someone just in the last day or so on Twitter was saying, if someone releases just the schematic of a project as a PDF, can they really call it open source? and that question opens up a whole big can of worms. I'm not going to get into that whole thing right now, but during the week, I got an email from Katie Bell, and many of you may know Katie from LCA. I haven't seen, well, the last couple of LCAs haven't really been the usual thing. So it's a few years since I've seen Katie in person, but if you attended LCA in person a few years ago, you may well know Katie. And so she sent me an email about some research work that's being done at the, where is it? This thing. Hang on, you can't see what I'm looking at. I'm going to switch back to the desktop. Where is my desktop? It is there and there. Okay. So what she sent me is this survey. University of Vermont is doing a study on how people receive credit for the tasks they do as part of open source projects. And so she asked me to share this around, and I thought, well, why not do it on a live stream? We can talk about this on a live stream. Folknology had a good idea. So Folknology said, this is feedback on the cat kit that we were just looking at a moment ago. You could include a cardboard template with 2 slots to correctly distance and hold the vertical boards. Yeah, assembly templates for this sort of thing can be very helpful, but it would also be tricky for Steph to produce. Although, I wonder if using the break. So this is waste. This is the part of the PCB that was that all the parts were snapped out of. I can't see an easy way to do it, but what would be an interesting idea is using part of this waste PCB as a template. Like you could have a couple of slots in it that are the correct spaces to hold the other PCBs in place. So what you do is you put the other PCBs into place prior to soldering, and you slot this in as a template to hold it, and then solder it, and then you need to take this out. And this is waste anyway, so it doesn't matter if it's got a few extra slots in it. But to produce something like a card would be trickier than it sounds, because you would need to do something like have it die cut into the correct shape, and that can be expensive. So yeah, it's an interesting idea. Oh, Brenda's here too. Hey Brenda. Yes, Steph is doing awesome things. So yeah, assembly jigs or ways to hold things in place while you are doing those solder joints would be handy, but how to make it without adding cost and effort on Steph's part is the tricky bit. So if it could be incorporated into the carrier PCB, like the waste portion of the PCB, that would be great. But with the really weird shape of all of this, I actually don't see how you could do it. There's no straight edge on here anywhere that you could just say, oh, I'm just going to put some slots in there and then use that as an assembly template. But anyway, it's a good suggestion. Yes. So, oh, and also I should point out, this kind of ties into the whole subject of open source credit. There is a tricky thing in relation to taking feedback on these sorts of things. And I get lots and lots of feedback on things that I do. Like people will send me emails. There are lots of comments on YouTube videos and those sorts of things. And it can be really, really hard not to take feedback personally. So in a situation like this, so I have just sat here and assembled Steph's kit, which she has put a huge amount of effort and creativity into. And going through that, it's very easy for me doing it and for everybody in the chat here watching it to be saying, oh, Steph should have done this, or Steph should have done that, or it would have been better if you'd done this. And often those sorts of ideas are quite valid, because once you throw this sort of thing out to a broad audience, you get other perspectives on things, you get ideas from people that have done things in ways that you haven't necessarily seen before. But it is often really, really hard to accept that, because partly depending on how people present it, and partly on how, as an individual, like just speaking for myself here, how I receive it. I've got no idea how Steph feels about any of this. I'm not speaking for Steph, but because I get feedback, and often I will get a lot of it can be very unthought out. Let's just say that. Like there was a bit of feedback I got on a video. There was a video I did a little while ago, and it's up on the Superhouse site, and there was a comment added to it maybe a week ago, and someone said, your diagram is wrong. I'd done a wiring diagram, and someone said, your wiring diagram is wrong. It should have been like this. And they had a link to a diagram, and the diagram that they linked to wasn't very well done, and it actually logically represented exactly what I showed in the video. So it was someone telling me off for not doing it properly and saying that I should have done it in a different way, and what they were saying was the way I actually did it. Like that sort of thing happens all the time, and it's very easy to take that sort of thing to heart. And I think that might be partly, that sort of thing might be partly why I have had a bit of burnout as well. And this is a difficult thing to talk about, because there are so many aspects to it. I can I'm not even sure where to go with this. Feedback is, I'll try to summarize. Feedback and getting other people's perspectives is incredibly useful and valuable. That's something that I've learned by doing projects in the open, like showing them on this channel as I'm working on them, and sometimes actually doing things live on the bench and talking through ideas and getting feedback from the chat. So I want that feedback. And the discussion that has happened around things like OXRS, the Open Extensible Rack System, and the firmware that goes in it in particular, and some of the ideas for other boards that can be built that go into it. People have had ideas and perspectives that I would never have come up with. And this is the real strength of collaboration within the open source community, is having so many people providing their input. But once again, the tricky bit is, as an individual, hearing that can be really confronting at times. So whenever I give feedback to people, I'm very aware of what it feels like to be receiving the feedback. And so I do my best to always be positive, and to make suggestions in a way that is going to not demean the person's work or make them feel like they didn't do a very good job. And it can be hard to do that as well. And if I have, I've probably stuffed up and given people feedback in ways that they thought they felt hurt by. And I wish that didn't ever happen. I'm sure I've done it. I can't think of any specific incidents, but it's probably happened. And yeah. So, and he just commented, backseat driving is so easy because that doesn't require all of the brain space of actually doing the driving. Critique is valid as long as it doesn't undermine the main activity. Yeah. So one of the things that I've found is that people who tend to give, I'm making so many generalizations here, people who tend to give harsh feedback or you should have done this better type feedback are not usually people who are also creating and sharing their own projects. People who do create and share their own projects know how this feels. And so it makes them more careful about the way they talk and present themselves when they're providing feedback. Anyway, I've gone kind of down a bit of a rabbit hole here, or chasing a squirrel. None of this is to say that that I think this kit needs improvement. Steph, you did a fantastic job. I really, really like this kit. It's the sort of thing that I would buy to give to people as like an introduction to soldering sort of thing. And I really, really like it. I saw a couple of comments. There was, I think it was Andrew Ruthven posted earlier saying that he's just bought one of your kits. So I hope you make lots and lots of sales out of this. Yeah. Anyway, Fred says, please ignore any feedback I give as I have no idea. No, I don't want to ignore feedback from people either. And this is such a tricky thing because I am also not saying that I will only take feedback from people who have built and shared their own projects, because you can get valid feedback, you can get really cool ideas from everywhere, from everyone. And so over the years, this is where I've kind of developed this, how do I put it? It's this self-image that I know nothing. And there are elements of imposter syndrome to it, but it's also a bit of that empty vessel sort of approach, in that I don't want to be in a situation where I'm working on something and someone comes along with a perfectly valid idea that would make that thing better, and I just reject it because I think, no, I'm working on this, I've been thinking about it longer than you have, I know what I'm doing, I'm on the right track. Now, that might be true, but the feedback might be something that gives me an idea, it might be something that improves what I'm working on. So remaining open to that feedback while also not feeling like it is a personal attack or something. That is the tricky thing. Anyway, oh, Dustin Will said, just started a new book, Humble Inquiry. Humble Inquiry. That's I have no idea what that book is about, but it sounds like it is related to this. And okay, one of the experiences that I've had a couple of times. So I've written a few books, and one of the tricks when writing a book is to, how do I put this? It is a really interesting balancing act, because you need to be enough of an expert that what you are presenting is valid and correct. You don't want to be writing a book that is going to spread misinformation or explain things in, say, the wrong things. But you also have to have yourself in the mindset of someone who is reading that book and consuming that information for the first time, as I'll say as a beginner, but this occurs at all levels of expertise. Someone who hasn't done it for ever, and this is the first time that they've come across this information. So I've heard a couple, over the years, there is this standard thing that people say, which is that the best time to write a book about something is when you're learning about it. And it has a whole bunch of benefits. Firstly, it means that you're approaching the subject with a beginner's mindset. You don't have preconceived ideas, and you understand and you see the things that beginners don't understand. So the barriers that you face and the hurdles that you face are probably going to be the same things that other people will face. And by doing that writing while you are going through the experience, it helps you to convey that and explain that process to other people. And so I used that to my benefit when I was working on Ubuntu hacks. So there were a few chapters in Ubuntu hacks that were on subjects that I'd never actually done before. I knew they should be documented. And one example was, so this was back in, when was Ubuntu hacks? 2007 or something like that, 2008. And it was in the fairly early days of virtualization on Linux. And so I wrote a chapter about creating and running virtual machines on Ubuntu. And when I started work on it, I had never actually done it at that point in time. And so I learned about the process and wrote notes and documented everything I was doing. I went down made false starts down certain directions and couldn't get things working, and then went a different way. So those false starts weren't included in the final documentation, because what I was showing was the golden path of how you get from the beginning to the end point, the sequence of the things you should do. But I was learning about those dead ends and side alleys as I was going through and learning and documenting the process. And the result was documentation that follows through from beginning to end on the golden path for someone who hasn't ever done it before. So that sort of approach can be very helpful. Okay. Oh, Wagon Load says, I sure hope I didn't say anything to discourage you, John. I don't know, Wagon Loads. I'm sure you didn't. Yeah, this is such a tricky thing, because I don't want to discourage feedback. Feedback is valuable. Everything I learn from other people. It's, well, that's not entirely correct, but just as a general thing, if you're not open to other people telling you things, then how are you ever going to get better at stuff? How are you going to learn? And so I try to be always open about things, and to keep my own ego in check, and be thinking, and this is the thing, is you could be the world's greatest expert in a subject, and someone who knows nothing about it, coming from a different field, might have a perspective with a throwaway line that makes you realize something new. Now, that is an unusual situation, but that can happen. So, yeah, I don't ever want to be closed off to that. Anyway, where this is all... Long Flare or Chip says, Jono, you sound manic at 1.75 times. I'm catching up as they had me watering the track in a noisy old fire truck. Yeah, so for those who don't know, Long Flare is currently at a racetrack, being a marshal or something for, yeah, there will be noisy race cars and all sorts of stuff going on. Now, where was I? That's right. What I was actually getting to was this. So this is what Katie sent me. And did I drop this in the chat? I don't know. Now that I've kind of restarted this whole subject, I'm going to drop this in the chat. So Austin said, OXRS. Austin, I don't think I'm going to get to that today. We shall see. This might take a little while. It might not. So this is the survey being done by University of Vermont. Now, I actually don't really know what the purpose of this survey is. It says what they are collecting. It's about how people receive credit for the tasks they do as part of open source projects. There will be an anonymous survey, takes about 10 minutes. We'll ask about your experiences with credit over the past 2 years. There'll be multiple choice and written responses. And you may feel uncomfortable answering questions. This is interesting. You may feel uncomfortable when answering questions in this survey. You may benefit from this study through the chance to think about your experiences working on open source projects. Yes, so it's not just them collecting information. It is like they are being a counselor. You're sitting on the couch and reflecting on things, thinking about how projects have been going, or yeah, a chance to reflect. It's all voluntary. Okay, so it's partially funded by Google Open Source. Google does not have any influence on the study, will not be able to see if you take the survey or not, and will not see your individual responses. Okay, so that's interesting. We plan to publish what we learned from this survey. We may share information with other researchers. We will not publish or share anything you could tell someone who, blah. All right. Okay, so what I had in mind, I don't even know if this is practical because I've got to write answers, I've got to stop and think about things, but let's just begin this survey. What categories? Okay, so this is open source projects, specifically questions asked about projects you worked on during the last 2 years and that at least one other person also worked on. So what they're looking for is something that is related to collaboration. The following categories describe things that projects either create or work on, which categories apply to the projects you work on. Now, this is during the last 2 years, so that's going to limit things. Definitely hardware, because I've worked on open source projects within the last 2 years that at least one other person has worked on. Operating systems, not within the last 2 years. Languages, not within the last 2 years. Frameworks, no. Libraries, kind of, maybe, because there are libraries in relation to, well, there is the library for the particulate matter sensor project. Yeah, stuff it, I'll put that on. Packages, I haven't done any packaging for a while. I think technically I'm still a Debian developer, but I haven't done any packages for ages. Applications, that, does firmware count? Something else, maybe. Let's break that out. Firmware as its own dedicated thing. Web related, not for a while. Data science, scripts. Yeah, the thing is that a lot of this comes down to whether I've done collaborative work on it, because what they only want is stuff that you've worked on with other people. So, firmware, applications. Applications, kind of, because I've just been working with Chris on a voice, on a soundboard / speech synthesizer system for use by people who have trouble with speaking. So, projects create for different use cases. Which use cases apply to the projects you worked on? Browsers, yes, because the, hang on. I'm trying to understand this question. The soundboard system that we done is a browser-based thing, but it wasn't a browser. I didn't work on a browser, but it's a thing that runs in a browser. All right. Content management, education, manufacturing, scientific research stuff. I don't know that I understand these questions. I think that watching me puzzle through these questions is probably a really, really bad idea. Mako, oh, thanks for coming along. See ya. Wagon Load says, I would never do any survey on Google or Facebook. Yeah, I know what you're saying, and that's actually why I highlighted that bit on the previous page. What I think is going on here is that this survey and this research is being conducted by University of Vermont, and they have received some funding from Google to do it, but it is not Google conducting it. So then there is the question of the trustworthiness of this and what it's going to be used for. They did say that their results are going to be published, which means that other people can benefit from the information that's collected. It is not like a private survey funded by one company and they are the only group that benefit from it. So hopefully there will be public outcomes that are a result of this. Oh, my throat is starting to need flushing. All right. Okay. So, projects create for different use cases. Which cases apply? All right. I'm going to read this as this is where it's used, not what it is working on. So, for example, it's not working on a browser, like I haven't contributed code to Firefox or whatever, but it is something that runs in a browser. So that's how I'm going to interpret this question. Business and productivity applications, not within the last 2 years. That was largely what I did previously. Communication technologies, content management, education, entertainment, manufacturing. Not really used in manufacturing, publishing, scientific research, software infrastructure. I think I'm going to say something else, and I'm going to say assistive technologies, because that is a lot of what I've done over the last 2 years. There is most of my contracting work, like the non-open source work, you would say is probably related to manufacturing and other things. Anyway, I'm just going to say that for now. I don't know. Tasks vary in size. For about 30 seconds, think through the different kinds of tasks you've done as part of these projects. Click on the right arrow. I'm not going to think for 30 seconds. Ask about receiving credit. When we talk about having received a credit, we mean the project told someone that you did something for the project. Oh, that's interesting. That the project told someone that you did something for the project. The more I go through these questions, the more I think this is really it's approaching the question with from the mindset of larger teams or medium-sized teams working on a significant project, not small open source projects that might only have a couple of people involved in them. Because those larger projects tend to have more of a public face. They have, excuse me a second. They have like a public website with information and lists of contributors and all of those sorts of things. Whereas a lot of the projects that I work on, even ones that are collaborative, they'll have a bunch of stuff on GitHub, but not necessarily, you know, a website with a registered domain name. Now, something like oxrs.io is the exception here, but projects like Calivox, which is the soundboard speech synthesizer project that Chris and I are working on, that doesn't have a website. It's not really a project. It doesn't have an identity really as a project yet. It's some stuff on, once again, it's stuff on GitHub. It's so far only the two of us that are working on it. And this is actually a project that I do want to talk about and demonstrate on a live stream at some point, because I am really out of my depth working on it and I'd like to get some input from other people. I think it's the sort of thing that other people can benefit from and also contribute to significantly, but it's not at that. It's not that right now. Johnny says, I maintain the Swedish translations for CircuitPython. They have a weekly meeting with Hug Reports, their version of Credit. Oh, cool. Aaron said, classic example of academic versus real-world data analysis here. Yeah, so Fred Flintstone said, what is their definition of credit? So that's this bit here. When we talk about having received credit for a task, we mean that the project told someone that you did something for the project. Those people may also work on the project or maybe outside of the project. So I think this is a situation like, say you're working on an open source project. Okay, say you had contributed to Tasmoda. I'll use this as an example because it's like right in our ballpark. And by our, I mean like you and the audience and me. So if you worked on a feature for Tasmoda, maybe a plugin or doing bug fixes or something like that, and then you committed those fixes, they end up in a release. There is a new Tasmoda release that comes along, there are release notes, and it will have a list of changes, and it will be something like bug fix
fixed buffer size for MQTT when receiving large messages. Like, I just totally made that up, but imagine that that was what was fixed. And then it would say, who did it? And that, I think, is the sort of scenario that this survey is looking for. That's what this is really oriented around. So it's not the sort of, yeah, it is, it's quite a narrow definition of credit, I think. So Austin's Creation says, these questions seem really skewed to force a certain result. Yeah, I don't, yeah, maybe. Yes. So Aaron said, 2 years is a lifetime. Most of us will be lucky to get 80 of them. Oh, Michael says, I'm in the changes file for asterisk 1.6. Well, that's pretty cool. Asterisk is a major project that's been going on for a long, long time. So, yeah, oh, this is a good way of putting it. Scott said, they seem to have made the assumption that all open source projects involve organized teams. Yes. Right. Yeah, I don't know if I should continue with this, doing this survey live, because I don't know, it is kind of interesting talking through this sort of stuff. I think talking about these questions is useful in itself. So, in the past 2 years, how many projects did you receive credit for your tasks? Okay, I am, given the context of everything that I've just said, I am going to say few of them, because I've worked on quite a few projects. Most of them are not really coordinated, organized teams. Most of them are projects that might have had a couple of contributors. Like, I've worked on something mostly myself, put it on GitHub. Other people have forked it, made some changes, submitted a pull request, I merged the pull request, you know, that sort of thing. That's the level of organization. It's not like, you know, a weekly stand up and tasks are assigned and we decide what we're going to do, all of that sort of thing. So they're probably the only one that comes close to falling into this category in the last 2 years, I would say, would be OXRS. So beyond 2 years, this would include MariaDB, because I contracted to MariaDB Foundation for a little while, and so I would have had, yeah, I would have received credit as part of MariaDB, but that's more than 2 years ago. We're just looking at recent stuff here. So I'm going to say few of them, given the characteristics of what I'm talking about in terms of the projects. In the past 2 years, how many of your tasks did you receive credit? Tasks? From how many projects did you receive credit? Oh, okay, I see the difference there. I'm just going to say a few of them. In terms of having my name attached to things, it's in commits on GitHub and things like that. So I'm just going to say a few of them. I don't know if you could hear that screeching. That was someone driving up my street with a slipping fan belt. It's I'm not actually sure where the car comes from, but it's a neighbour just down the street somewhere. And several times a day they drive past and I hear the screech of that fan belt and I want to run out and say, give me 1 minute and I'll fix that for you. But I don't actually even know whose car it is. It's just a little white car that sounds like it is trying to kill its fan belt. All right, now projects give people credit for tasks through different mediums. Through what mediums did you receive credit? Select all that apply. Automated metrics, e.g. GitHub contributors. I think I have. I can't actually remember, but probably. Project membership. I am In fact, I am technically still a member of the MariaDB GitHub organization, and and a couple of others. So yeah, I'm going to say yes because OXRS has a GitHub organization, and so does Superhouse for that matter. I suppose you could consider that Superhouse is a project. Project documentation, maybe, I don't know, standardized tools, contributors, credit. I don't know what all contributors or credit are. I've never heard of those. Social media. So this is external. I'm just going to say no on that. Blogs, no. Presentations, not that I'm aware of. So this is talking about other people giving me credit, not me getting up and saying, hey, I did this thing, which is like self-credit. I'm not sure. I'm going to say, yeah, I can't think of any other ways. That'll have to do for now. How satisfied are you with the mediums through which you receive credit? Don't care, really. I'm not looking for more credit, just the fact that my name is on a commit or something, that's fine by me. I don't care. So, no, satisfied, not dissatisfied. Think about all the tasks. How often did 2 or more people know that you performed those tasks? I would say often, maybe, because the things I do tend to be quite public, and particularly when I work on a project or a video about it, and then other people will download the firmware or do the thing, whatever. So I'm just going to say often. But yeah, I don't think the circumstances that I'm in really align with this particular survey. How often did one other person know that you perform those tasks? I don't know. Often. How often did nobody else know that you perform those tasks? Rarely? Maybe? This doesn't feel right. Like, the way I'm answering this doesn't feel right, but I think it's the best I can do in the how satisfied are you with how many of your tasks receive credit? I don't know. Satisfied? How important is it to you receive credit for the tasks you do? Oh, this is interesting. Okay, so this is getting into a subject that I thought this survey would touch on a little bit, which is partly the motivations for being involved in open source projects and how important it is to receive credit. So for me, I'm going to... All right, this is going to be contradictory based on what I've said previously. And I think this is a subtlety that this survey really is not going to be able to elicit. So in here I said, I am satisfied with how many of my tasks receive credit. And now I'm going to say very important in terms of receiving credit. Now, why? This gets into something that I was wanting to talk about probably totally independently of this survey. And I'm going to... how far down this rabbit hole do we go? Or how far do we chase this squirrel? Okay. This is time for a bit of self-reflection, just momentarily. Why do I do things as open source? Why is it that I design things and then stick them on GitHub so other people can make use of them? There are a bunch of different reasons. There are altruistic reasons, there are selfish reasons, there are practical reasons, and there are a whole range of reasons. But where I'm getting to in relation to this specific question, which is how important is it to receive credit for the tasks you do, a bit of it is ego. It is wanting other people to say, hey, you did a good job with that, or the fact that I was here mattered and made a difference. So being totally altruistic and simply doing development work or creating projects and sharing them so that other people can benefit can be done entirely anonymously. And I don't work anonymously. I'm quite visible in terms of the things that I do and attaching my name to things, to the extent of, and this is something that feels kind of weird, and there's a whole backstory to this, but to the extent of sticking my name on PCBs that I design. I don't always do it, but sometimes I do it. You might have noticed on some PCBs, like on the, in fact, I've got, hey, we're not going to get to this subject today, but here I have a whole tray of Rack 32 PCBs that I assembled yesterday. And on the Rack 32 PCB, it says Rack 32 by John Oxer. Like, it's actually got my name on it, which is a very egotistical sort of thing to do. And that is, it partly comes out of my original idea for Freetronics and what Freetronics should be. And this was like, so when was this? 13 years ago. My idea was that Freetronics would be like a publishing company, like a book publisher, but instead of being a publishing company for authors, it would be a publishing company for designers, like electronics designers. So when you buy a book, it is name of the book by the author. It'll be such. Where's a book? What have I got here? I don't even have, I've got a whole bookcase full of books back up there, but you know what I mean. It is book title by author. And the idea is that if you like that particular book, the style of the book, then maybe you will want to read other books by the same author. So author credit for books is important in that sense. It's recognition of who it was that created that work. And my idea was to provide a service to publish or manufacture the designs of other people. And so very early on, right at the start, I really conceptually, I took that concept and applied it to PCBs. So even some of the early Freetronics projects, you will see that on the circuit board, it'll say, like some of the very early ones, like the Ether 10 early designs, it says Ether 10 by, and then on the PCB, by John Oxer and Mark Alexander, because the two of us worked on that design together. And the idea was that that was like a book title and author credit. So, yeah. What was, I've just been seeing comments in the chat, and out of context, I don't really know what it's referring to. Aaron said, yep, like I said above, socially acceptable hug coming your way, John. What did Aaron say? Just remember, you show up on streams most weeks to show support though, Fred. Yeah, okay. I've kind of lost track of what's going on with the chat. Aaron just said an artist should sign their work. Yeah, that's another way of looking at it. And so, okay, and it can be tricky sometimes when thinking about it from your own point of view. Okay, let's go back to the amazing little cat kit from the start of the stream by Steph. Now, I'm not even sure if Steph, put her name on here. Elkie Education. Okay, so this little kit, I'm gonna get those. I just dropped the cat's arms on the floor. Elkie, it's got the company name on here, but this kit, I better remember which way around these paws go. Is it that way? Feels like they go that way. No, I think, oh yeah, it goes that way. I'm looking at this from the wrong side. Anyway, the I admire what Steph has done with this, But if I saw this on someone's shelf and picked it up and looked at it, I would see Elke Education. So it gets like a company credit, but it doesn't get an individual artist credit. And I really think Steph's name should be on this, signed as the artist, because this is not just it's not just a piece of engineering, it's a piece of art. And yeah, okay. I don't know where I'm going with that. Right. Can you own a thought? There are all sorts of things, interesting rabbit holes we could chase in the chat here. All right, so what I was talking about here was justifying why I'm giving this answer. So I've got, how important is it to you to receive credit for the tasks you do? And I'm putting very important because conceptually, I think that I think it is important, not just from my own perspective, but I think in general it is important to give credit to people for the work they do. And I like to recognize other people's work, and I also like to have my own work recognized. So I'm going to say very important. Anyway, moving on from that. Thinking about how the projects you worked on gave people credit. From your perspective, what worked well about how they gave people credit? What worked well? I don't really have a very big sample to work from, so I'm not really quite sure how to. Okay, what worked well about how they gave people credit? I do think I like to see in things like release notes, as the example I was using before of Tasmoda. What I do like is when there is a major public release and it has a list of things that have been done, to have names of people that contributed, particularly if they're external. And I think this is a really good way of encouraging people. If someone has they come across a project and they have an idea, or even if it's quite minor, like it might be improving, like fixing a spelling mistake, for example, in the user interface. Technically, it's not a challenging thing to do, but it is important in terms of polishing the project and increasing its overall quality. So if you came across a project, you didn't have a background with that project, you made that little improvement, and then you contributed it, and that change ended up being merged into a release, I think it would be nice in the release notes if it had an entry there that said user interface improvements or spelling corrections or something like that. It doesn't really matter how you say it, with the person's name, because what that gives them is a feeling that their contribution is valued, and I think that's really important. So it's providing positive feedback to the person that's made that contribution. And yeah, so Eastig V2.0 says, I want a cookie. What is going on with this Eastig V2.0? Grammatical fixes? Yeah, so there are different ways you can credit it. I mean, I didn't want to get into the specific example of fixing a spelling mistake, but the point is that it doesn't really matter the scale of the contribution. It could be a multi-month major rewrite of the code, or it could be a spelling correction. Now, obviously, people do need different levels of credit, or what they're credited for will be different. But I like the idea of being inclusive in terms of credit. So even what many people would consider to be minor contribution, it's still a contribution, and I think it should still be credited. So for this example, from your perspective, what worked well about how they gave people credit? I am going to say, I wonder if this is the end of the survey. Not sure. It looks like I've got most of the way through. This is very much like a wrap-up question. Is there anything else that you'd like to share with us? So think about the projects you worked on and gave people credit. From your perspective, what worked well? Oh, looks like, hang on. I think we have an invader. We have an invader. What's going on here? Hang on. I want a cookie. I've just been handed and I want a cookie post-it. I want a cookie. No cookies. I'm like, I want a cookie. It's escalating. There is someone Darth Vader breathing over my shoulder. I want a cookie. Yeah, okay. 3 times. Okay, I think 3 times deserves a cookie. I have cookies here. Amazingly, these are cookies made by Steph Piper. So I think I'm going to have to hand over the cookies to, I think this is Eastig V2.0. Yep, I'm going to give up my cookies. Eastig says it's lunchtime. What's this? What have I got? Ooh. I've got a little PCB in a bag. Eastig is gone. That was strange. Well, we've just had a lab invasion. Okay, I will just wrap up that thought before I call lunchtime. This is a very interesting little board. It is a temperature-based anemometer. I'm gonna chuck this very briefly on the overhead camera. Where do I go? Overhead, and so this board has a couple of temperature sensors on it, and the idea is that it measures ambient temperature and it measures wind chill, and from that it figures out what the wind speed is. I think that's the way it works. So Eastig just handed me this weird little PCB. This is going to require future investigation. That's a really interesting one. For now, I'm going to chuck this back in here, and I had better wrap up because Eastig told me that it's lunchtime. I don't normally get messages like this delivered personally by the Black Stig. All right, so there were just a couple of questions left in that survey. I am going to once again drop that survey URL into the I've totally lost it now. I don't know what's going on. Okay, so that is the survey. If you feel inclined to help Katie out with this research, go and check out the survey at University of Vermont. I'm going to finish the last couple of questions off like later. I'm just going to leave that browser open and get back to it. But for now, I think I had better go and see what the Eastig V2.0 is up to and see if he's just eating Steph's cookies for lunch. All right, I'd better wrap it. Hang on, I better figure out how to wrap it because I'm doing this odd thing. Oh, slightly off camera here. I am doing this odd thing with the, where are we? With doing my live stream entirely off the ATEM, I've got no OBS. I can't actually like do the outro thing. I've got to throw to a laptop. So I hope this was interesting today. Thank you very much, Steph, for sending me the kit for the cat. That is a really, really clever kit. And those little badges as well, like the, I didn't do the assembly on them, but these little badge kits that Steph also sent me, they look cool. They're smaller, simpler, cheaper. So if you're after something that isn't as elaborate as the cat kit, those are good ones to go for as well. And Peter says, just turn the power off, John. Yes. Okay. I think I have worked out a way that I can throw to a closing like screen. So Have a very good Sunday afternoon or Sunday morning or Saturday night or whatever it is, wherever you are in the world. And I will talk to you really soon. Okay, thanks. See ya.